Hello, this is a deep dive into several aspects of the BreatheRight product design. First, I'll begin with talking about some of our housings. So right here, we have two housing that will be used for the two separate inhalers. We have one for a disc inhaler, and we have one for an MDI. They both have all the same features that are mentioned in the paper and in the videos. And then right here is a mock-up of what it will look like for injection molding. This will have to split up into two parts so it makes sense for the molds. Next, we'll follow a demonstration of the PEF readings and the pressure sensor, then an explanation of the predictive abilities of our device and a demonstration of the gyroscope.
Here is a video of our device demonstration. So in the beginning of the video, I'm pressing the button for 5 seconds and blowing into the p-flow meter as hard as possible to calibrate the device, and this will be stored as the maximum PEF value in the device. And then I'm going to be taking a series of measurements by blowing into the p-flow meter at different speeds, and the color of the LED light corresponds to which PEF zone I am in. And towards the end of the video, you will see that I will be applying pressure on the pressure sensor, and this will be used for medication tracking purposes and indicated by the yellow LED light.
This is going to be a demonstration of BreatheRight's predictive capabilities that we have imparted onto it through the use of digital filters. What you see here is a graph, and there will be two lines that are plotted as the user takes new PEF readings throughout the week. The black line will be the actual measured value that is taken, and the blue line will be the calculated values that are taken and used by our device. We also have two little boxes on the bottom, which is the light shown on the device, and that is just indicative of the measured value. And the warning message on the app is going to be what is sent to the user if the new reading that's predicted is in a new zone than the actual measured value. What you will see here is our predicted value is always one step ahead of the actual measured value. Therefore, you can see that the color always changes on the right box before the one on the left, which allows us to send a warning to the user and actually allow them to take preventative measures so that they can make sure they don't actually have that asthma attack. Here's an example of the predictive capabilities of our device. On the graph, black represents the current value and blue is the predicted value that BreatheRight calculates. The status LED shows the current peak flow zone, and you will see that it shows green, but the downward trend in the graph causes the predicted value to enter the yellow zone, which sends a warning to the screen, and then it disappears as both values enter the yellow zone. This is a demonstration of the gyroscope that exists within our device. Because we have an Arduino microcontroller that contains a 9-axis inertial measurement unit, we can actually measure the angle at which the user's inhaler is going to be held. Therefore, we can give them feedback that allows them to know if they were holding their inhaler at the correct position to actually allow them to administer their medication correctly. So what you will see here is as the breadboard is tilted, the value will be going further and further away from 90 degrees, which is actually perpendicular. So what we're able to see is that you can actually tilt it in multiple directions with multiple axes, and you can still get a change in angle.